Good afternoon, ladies and gentlemen. This is Mr. Chen for a supplementary lesson on logarithmic functions. This might help you with your exponential lesson that we've been talking about. At any time, feel free to pause the video, and you might need to actually Google or research some logarithmic functions because it's not really in the grade 11 math curriculum, but I think it might help some of you to understand why we need to solve it or solve the equations, especially when we want to find the x-intercepts for our graphs. Now notice some of the graphs actually don't have an x-intercept, but there's a way to figure things out. So hopefully this is going to show you. And this is a fast way, and some of you actually might find this useful, especially next year in grade 12. So let's talk about, first of all, what logarithmic functions are. The definition is given that a function, an exponential function, a to the x, its inverse is called the logarithmic function with a base of a. So that's what that is. So what you're seeing right now is a new mathematical operation called logarithms, or log for short, L-O-G. And as you see on the screen, and hopefully I can highlight it, the way that you say this, log of base a of x is equal to y. So one more time, log of base a of x is y. And the understanding is it's the same thing as a to the y is equal to the x. So notice that the a is the base, and the y is the exponent. And it's equal to some value, right? So this time, what we're trying to do is find the unknown exponent. So in other words, log of base a of x is the exponent to which the base a must be raised to x. So let me give you a specific example that might be easier for some of you. A lot of you actually understand this. Solve 10 to the x, which is equal to 1,000. Most of you actually know what this is. X, because it's our known, is equal to 3. A lot of you actually intuitively know this. If we do a similar example, 10 to the x is equal to 100. A lot of you actually know what x is equal to, and that's going to be 2. But what happens if we wrote it like this? 10 to the x is equal to 900. Well, this is not so easy. And a lot of you know it should be between 2 and or 3. And this is where logarithms actually come into play, because the unknown, it's not that easy. It won't be 2.5, it won't be 3, it won't be 2. It'll be in between 2 and 3. We just don't know, right? So it's not super clear. But that's why, hopefully you kind of understand why I'm trying to show you this. It's obviously related to exponential functions. Let's just scroll up. Oopsie. So some properties that we have to go through, and I wanted to do a pretty good job to show you. And as you can see in the screen, if you have to pause it, feel free to. But this kind of makes sense. So there's these 4 property logarithms, and right beside it is the reason. So one more time for property number 1, log of base a of 1 is equal to 0. And what that really means is that a to the something must be equal to 1. And what would that be? Well, we must raise a to the power of 0 to get 1. And that's why that is written like this. So I'm still going to translate the logarithmics into an exponential form. Same one with property 2, log of base a of a is equal to 1. I think a lot of you understand that. A to the something that must be equal to a, that had to be 1. And so that's what the unknown was. So we must raise a to the power of 1 to get that a. Here's the one that I'm trying to get to, the third one. Log of base a of a to the x is equal to x. We must raise an a to the power of x to get a to the x. And I'll explain that with another example. And finally, the fourth one, a to the log of base a to the x is equal to x. And log a of x is the power to which a must be raised to get to x. So this short video is hopefully going to show you something that we need to do. Now, I don't know why this transferred over. I apologize. Maybe when I was scrolling down. Nonetheless, here we go. So what we're going to do is these two examples, question 1, and for some reason, oh well, it's too late now. I don't care. We have 2 to the x minus 4 is equal to 0.25. So I'm going to show you using logarithms. Now, you don't have to use the first one for logarithm. You can actually use base of 2, but use logarithms. And I'm trying to show you how it works. It's obviously the third property that I'm going to look at. And maybe I should write that in blue so some of you can see what I'm trying to do. So basically, log of any base a of, let's say, b to the x is equal to, actually, that's not right. Let me just erase that. Let's try that again. What was I trying to get? Well, just the log, basically what we're doing is log of base 10, and I'm not going to, the 10 is really there all the time, but what I'm trying to show is that b to the x, log of b to the x, there's a very important power rule that actually happens that the x can come out, and then we can get the log of base 10 of x. That's what we're looking at. So when you do something, typo. My fault, ladies and gentlemen. My third time doing this. So try to use logarithms for this, and you'll see hopefully that what I'm trying to do. So for this question, 2 to the x minus 4 is equal to 0.25. What we're going to do is we're going to log both sides. So log of 2 to the x minus 4 is equal to the log of 0.25. Whatever you do to one side, you must do to the left side, right? Left side and right side. So using this blue rule that I have on the screen, the x minus 4 comes out, and what we get is the log of 2 is equal to the log of 0.25. And just like mathematical operations, the opposite of multiplication is division. So if we divide both sides by log of 2, you're going to get this. Okay? And then when we're going to solve for that, find on your calculator the log function of 0.25 divided by the log of 2. And hopefully you get this. X minus 4 is equal to negative 2. And then what are you going to do? Add 4 to both sides, and x equals 2. Now I'm just going to scroll up before we do this second question. I wanted to show you that we could actually have done this problem without the logarithms. Oops. I don't know why the screen is. Anyway, so I'm going to just show you in green how we could have done the same question, but without logs. So hopefully it's okay that I change that to a fraction. 0.25 is a quarter. I don't know where these stray marks are coming from, but that's okay. So to do this question without logarithms, this one is actually easy. It's because some of you know what I'm going to do. I'm going to try to get the same basis. When we have the same basis, we can get that on the right-hand side. And then that 1 over 2 squared is actually the same thing as 2 to the negative 2. And once we have the bases the same, once we have the bases the same, their exponents are the same, or they can be equated. So x minus 4 equals negative 2, and x equals 2. Notice the very first example, that's why you actually don't need to use logarithms all the time, is because sometimes if you have the same base, it's so much easier. But question B that I have on the screen is not the same as our first question here by example. We have 4 times 2 to the 3 to the x is equal to 7. Notice our unknown, again, is a variable, right? So the first thing we have to do is divide both sides by 4. Because according to the reverse operation of BEDMAS, we deal with adding, subtracting first, multiplying by dividing second, and exponents third, and then, of course, the brackets. So we're going to divide both sides by 4, and I think we get 1.75. And now let's see if we can do the log. This time I'm going to hopefully show you what I'm trying to do. So when we log the left side, we have to log the right side. And what that happens, what's really neat is there's a logarithmic rule that lets the 3x come out. And it's not always going to be log of 2, but in this example, in these two examples, it is. It's usually solving for the x-intercept. So then we keep on going. What are we going to do next? The opposite of division or multiplication is division. And again, I'll just highlight this for you in green. So you see that multiplication there? The opposite of that is to divide. So you take out your calculator and you get the log of 1.75 divided by log of 2. And I actually did this off screen already. And I think we get, oh, maybe I didn't. I think I solved everything and then I divided by 3 again. Well, let me just do it really quickly. So log of 1.75 divided by the log of 2. I got 0.807354922. And then solve for x, divided by 3. And I get 0.269118307. And it probably keeps on going. But that's the unknown. And the only way you can kind of check this answer is if you place this long decimal answer, and this is why this is hard to kind of to figure out, this whole decimal figure, into the equation, original equation, and you can check to see if it actually equals to 7. So why don't you check that? You do 3 times that 0.269118307. You're going to get a weird answer. And you do 2 to that answer, then multiply by 4, and it should equal 7. So hopefully this helped you a little bit of understanding some logarithms that might assist you in understanding how to find the x-intercept. Again, if you can get the same bases, the first example I showed in green, even though I did it second, is probably the better way of understanding. But if it's not, meaning if you actually graph something, that's actually how you solve it, rather than just doing a simple guess and check. I hope this was a little bit helpful. At any time, feel free to email me if you have any questions or concern. Thanks for watching.